Well, good afternoon, ladies and gentlemen. Thank you all for coming. My name is Young Liu. I work for Argonne National Laboratory, which is one of the U.S. Department of Energy's national laboratory. In fact, we are the first. Was founded in 1946. So today's workshop, the topic. Okay. Um, Let me go from the front page. The title of the workshop is called the ARGUS, ARG's Argonne, US Remote Monitoring System Technologies. And I came in at the tail end of the last workshop presentation, so there may be some similarities because I heard the speaker talk about digital twins and data and all that. So my talk on this ARGUS remote monitoring system um, really has two platforms. Our main work at Argonne is on packaging certification, and on the right-hand side you see all these transportation packages, for nuclear and radioactive materials. We certify those packages. They are moved in the public domain, so it has to meet the regulatory standards and all that. The Argus itself is a remote monitoring system. Um, the system can be used to enhance safety, security, and safeguards, the three S of nuclear and radioactive materials. What I'll be covering is the two platforms. First one is we call the smart drums. It's RFID, radio frequency identification, text and the reader. And the second one is the wired and wireless. RAM stands for Remote Area Modular Monitoring System, and Traveler is for transportation. I did have a pass out which summarizes, the topics that will be covered, and there's so you can take your time and look at them. I will also be here for the next 2 days, and my booth is E as in Edwards 018. So after today's workshop presentation, if you find this interesting and you would like to learn more, either we can do this afterwards, at the other area, or you can come and visit us at the booth. I'm the only one here. So with the RFID, radio frequency identification surveillance tech, the frequency range is 433 megahertz. If you know on the radio waves, the important thing is that between this wireless communication, what is the range, right? This range is actually close to 300 feet. Okay, so you can think of a center have a reader, and then you draw a radius of 300 feet, and every text in those within that 300 feet radius will be picked up by the reader. And what you're seeing here on the upper right-hand side are the contract manufactured RFID tag, and on the bottom, on the right-hand side, there are different kinds of regulatory certified drum-type packages. And these packages are designed to withstand the regulatory accident, which is pretty severe, and then is still able to retain all the radioactivities and provide shielding. And then if the materials are fissile material, nuclear, and it will not go critical. So the tag has a universal form factor. It's different type of drums, so the attachment to the drums will be different. And yet all of these has already received a license from the U.S. Department of Energy for use. And On the RFID tag and also on the remote monitoring system, if there's a takeaway message that you can, want to take with you, is that you basically need three things. Okay, one, sensors. Two, ability to communicate, whatever the sensor measures. Okay, and three is the power supply. Okay, so just keep those in mind, and I'll show you in a schematic fashion, how this thing works. And on the right-hand side, there are the drum type packages. And upper left one, the green drum, we have a RFID tag attached to the drum. And that tag communicates wirelessly with the readers. And the one down below is we call the all-in-one COM box. And that is you have the readers, you have the communication capabilities, you have the batteries. So all three, right? And on the right-hand side, you can see that once you place the materials inside the drum and you close it, you put a tag on, and from that point on, it basically you have a pair, a drum, a tag, and the drum. And all the materials information, the manifest, is in the system. And whether the drum is in a storage facility or is in a truck or in a moving vehicle, it can be tracked. Okay, and the tracking is actually 24/7. Okay, and because the tag has the suite of sensors, so there anytime a sensor alarm, then one can set the high and the low, and if the alarm threshold is crossed, automatically the message alert warning is sent. So this is one example. This is actually back quite a while. We did a demo. This is RFID in the tactile seal alarm. Tactile seal is the one that we put it underneath the attachment to the drum. And when you tighten the bolt, right? When you have a drum and think about it, you have to open and close, open to put the content in, and open again and close it, and then take it out, right? So this tactile seal alarm is actually alarmed under the torque of the bolt. And when that bolt is loosened, even a tiny bit, the impedance level changed by 4 orders of magnitude. It's very sensitive. And this demonstration is when we put the drums in a vehicle, and you see the, by colors, and then we put into a parking lot on what we describe as in transit a stage incident. So someone loosens the bolt, and then it sends off the alarm, and we know the response time. And when you are monitoring on the web page, we use the color to indicate green is everything is normal, right? Red is then you have an alarm situation, and then the color changes. And at the same time, the messages will send. And you can pull down the drop-down menu and tells you which sensor sets off the alarm. And again, when you have an alarm, the immediate reaction is for the person in the field to ascertain the cause of the alarm, right? I mean, if the cause is a false alarm, for example, or it's not really a threatening situation, then you can have a basis to clear the alarm also remotely, because in the vehicle situation, the driver's job is to drive the truck. It's not double duty as a security officer. So all of these is automatic. And so that's on the RFID set. And when you look at how this whole thing fits together, it's a drum-based remote monitoring system. We put a tag on, and then you can look around, the circle here, and then think about what else can you incorporate into this. And these are the arrows that point to different directions. We at Argonne, of course, we did this. We have a place to showcase this thing, in real time. But it also ties to the geographic information system. That's where the emergency response comes in. And you can, because the tracking with the cellular or satellite with the GPS, you basically know when things happen, right? Where it happens, when it happens, and what is it, right? And then you'll be able to respond accordingly. So moving on to the next platform, and this is called the Remote Area Modular Monitoring System, the abbreviation as RAM, and that's 2.4 gigahertz. So this is like I don't know if you heard of the Zigbee standards, but in the commercial arena, it's quite, that frequency band is often used. And for us to design the system for nuclear facilities, so because the fuel cycle facilities, this may be a nuclear power plant, right? And we will have go in there and pre-configure for the fixed readers, strategically located, okay? And it has the right kind of sensors. And imagine an event like Fukushima, okay? Reactor accident. Immediately happened is that we never thought that we have such a huge tsunami wave that basically overwhelms the emergency power, system, right? You lost the grid. And then emergency responders then go in, but at the same time, the reactors, they're pouring, water, seawater, right, trying to cool the core. And as it happens, you can go, if the core melts, then you can go recritical, right? So emergency responders, I think in the first 72 hours, it's very, very important that you have a system, and because you cannot see radiation, you cannot see release, but it will tell you, okay, what that, we call it situational awareness, for the emergency responders. But from the power supply side, if you lost the grid, what do? So we have a battery backup. And this from the grid to battery is automatic, right? Routine operation, we run it off the grid. Everything is normal. But when there's an accident, it automatically switches to battery. And all we're looking for is 72 hours of awareness time. And the sensors will tell you what the situations are, radiation levels and all that. And then getting back on the basic concept about remote monitoring. Okay? And this is on the right-hand side. In the remote monitoring on the sensor side, I mentioned that the seal is important because somebody, are they people tampering, with your stuff. Camera is also very important. Now, people don't even often think about camera as a sensor, but for us, it's an optical sensor, right? And it takes pictures, it can do the streaming, and all of those. And then you have the communication capability, right? Go up in the sky, cellular or satellite, and then be able to come down on Earth, to the receiving stations. And now that we have internet access anywhere, so basically you can monitor this from your smart device. And now moving to the left-hand side, I mentioned earlier about the safety, security, and safeguards. And these are typical, we call the vein circles, right? You have a safety in one circle, security in one circle, and then safeguard in one circle. What's in the middle? That middle is the packaging, right? Because nuclear and radioactive material, you need the packaging to put them in, and then you monitor them, okay? So in our jargon, say the 3 C's, and once at the bottom we say during the life cycle, you want to maintain. One is called the continuity or chain of custody, right? Passing hands from storage to transportation to receiving. And then you want to have a continuity of knowledge, right? What's in the packaging. And the last but not the least is the so-called confidentiality, availability, and what's the other one? I always remember like CIA, right? That's the 3 C's about it. So, and moving quickly to the RAM, the sensors and the digital camera. our system is modular. It's modular in the hardware, in the devices, in the kind of sensors you want to incorporate. It's modular in terms of the communication. It's modular, in software as well. So this is one example. And the only one I want to showcase is that digital, basically a webcam. Okay, we can put that inside this enclosure. If you have this monitoring box, somewhere in the facility pre-installed, and you have a fixed point of view, right? Your camera. The camera can also you can move the camera as well, but that consumes power. And that may not be the one that you want to do. But we also have provisions for doing the camera as a USB device. So it's a plug-in, external to the enclosure. And you can see that on the sensor side, they have basically the same suite of sensors to select from. At our lab, we have the capability of doing this, vertical integration, down from the sensor all the way up to the system. Okay? So this is one case that shows the applying of the two systems is one radiological facility called the Alpha Gamma Hot Cell at Argonne. It's a radiological facility currently under decommissioning. And the top is the RFID system. And that's been there for, it's 2013, I think, was the first year that we put it in. The bottom one is the RAM system for facility monitoring. That's the one I mentioned about the cameras, right? That one, we put it in 2018. And this system are continuously running. Somebody asked me earlier this morning, say, can you do a live demonstration? If I had my own laptop and very possible, not possible, I can happily, do that for you. Sitting here, you know what happened thousands of miles away, at home in this facility. Okay? So, and think about what the remote monitoring system can do for us. Is it advancing? Sorry? Is it advancing? So that's one example on the plain view of the facility. This shows I have 3 RFID readers, and I strategically placed them, to cover the first floor of the whole facility area, the front and the back, right? And those are the star shape are the readers. The one on the bottom is actually on the second floor at the fan loft, because that's where you have in the hot cell where your HEPA filter is placed. And you want to know if something going on in your facility, release that comes to the stack, right? And the cursor, if you point to the circle, these have a 7 RFID tag on it. And cursor put on this one, this actually near the glove box, right? And then it drops down to all the sensor readings. And when you look at the color, it's all green. That means everything is normal, okay? And then on top, I have a dotted circle, and that's if you can read, it's called a multiple camera view. So there brings up the camera. Okay, these are the other system, right? The other system being up the camera. And this gives you basically the near 100% coverage of all the accessible area on that floor, okay? And what we do is that we have a today, and the camera is actually programmed to take pictures, okay, every 2 minutes. So 24 hours, you end up with 720 frames, right? Pictures, 2 minutes apart. That's today. And so what I do provide is that you can actually look at the camera and think about how do I set up sensor cameras for event, for intrusion, right? I would say this Alpha Gamma Hot Cell has a normal operating hours. So evening hours, weekends, not supposed to have people in the facility, right? So if I want to train my camera to cover the critical areas in the facility, is where the activity took place. Right? On the backhand side will be the clean transfer area when you offload, right? Materials getting in, take it out. The other one is at the glove box, right? Glove box means that you have people coming into the glove box, stick their hands into the gloves and do some work. And that's the event detection. And the way we do it is that we detect the change of the pixel intensity because the wall doesn't change, right? The color, those things don't change, but the technician walk into that view in front of the glove cell, hot cell, or glove box, then it's clear, right? So this one, doing this kind of event detection within 2 minutes. In 2 minutes, that person walking, he changes the pixel intensity, and we know it. There's an alarm, okay? And this has a timestamp down at the bottom, right? And the reason I circle this clock on the wall, that's a real time, right? So we do something that you want to have independent sensors, which in this case is simply a wall clock that validates the image. And here I had on the right-hand side, so 720 frames. When you think about it, it's actually very useful because on the top of the bottom, I showed it today, and then you have the basic by day archive, okay? So if you have an event, basically what happened before that event occurs, right? Allows you to go back. This actually is very good for forensic investigations. And since I have the 4 cameras in the facility and it's programmed, and I can do the playback 16 times. And these are all synchronized. So it's very quick to zero in on the event itself before and after, okay, for the investigation. Now for the operations, if you are a facility manager, you come in, you know what's going on in that facility today. Are my technicians, workers are wearing the right suit, right? So I can, in the morning, pick up this and then see what goes on, right, in the hot cell for operation. So this is another version of the, I think I'm moving on to like a traveler now. But it's the same, the physical dimension of this is like a lunchbox, okay, lunchbox, literally. But inside, you can do batteries, you can do cameras, you can do external cameras, and this happens to be a pretty decent heavy-duty lithium-ion rechargeable batteries as well, okay? So with the Traveler, the way to implement other useful tools, on the command side, you see that I can set the sensor thresholds on any sensors, max, minimum. I can set the polling interval. Polling interval means do you want to sample get the sensor reading every 2 minutes, or 1 minute, or 5 minutes, but that really depending on the threat environment that you're seeing, right? Our typical is like 2 minutes. And the reason we choose 2 minutes, I mean, if you use microwave ovens, just to heat up your coffee, you know how quickly that time goes by, right? So within 2 minutes, if you get the alarm, and when the alarm situation arises, that is plenty enough, okay? So that's on the command side. But on the notification side, it's also interesting because this allows you on the pre-arrival notification or when you're crossing state boundaries, right? And of course, alarm. Alarm situations, really the key things is when did it happen, when it happens, where did it happen, and what is it? Okay, those three W's. Okay, so this is one test case or use case. It's actually a shipment of pressurized water reactor fuel assemblies from a fuel fabrication facility in South Carolina to one of the utility customers in Wolf Creek, Kansas. So the entire trip was covered, right, with a traveler system. And then what else can we use the traveler on? And we think about the nuclear fuel cycles, the UF6, uranium hexafluoride, for the nuclear, right? And then for the waste, the true waste to the waste isolation plant, fresh fuel assemblies, and also the last one is for the radiological sources, seal sources, or even the RTGs, radioisotope thermal electric generator. I think my time is up, but this is a summary in the future work. Highlights I basically covered, through the talk, and at Argonne, being a national lab, we're not government employees. We are called contractors who work for the government. But it's basically taxpayers' dollars to help to fund the national lab, right, for Department of Energy. But for us as a research engineers, we want to see it used, right? So if this is an innovative product, and our approach was we should apply for a US patent, right? And after the patent is granted, have a company license the patent, so make it available if somebody else, others, want to acquire it. Now, with regard to the future work, I can tell you that right now the focus on the transport emergency response, and that is, when you have an alarm and you ascertain that there is an incident, right? What do you do? Okay, so that's an area that we're focused on. The other area is the environmental monitoring. Okay, we've done the facility, we've done the transportation. What about the environment? So I have one example to show you, how far we have gotten in that area just in the last 2 years. So this is that same RAM box, but it's outdoor. And the camera was trained on the delivery area of liquid nitrogen, okay, for one of the accelerators. And then the environmental monitoring system is on the other side. And this year we're going to Idaho National Laboratory or National Idaho site, to put our systems to do the environmental monitoring. And I will save the last 2 slides, and we'll go through it because my time is up. But when you think about safety, security, and safeguards, what are the causes that give rise to an incident? What is the goal, right? And then I have one more slide that shows, we call the packaging 3S by design, right? You design a package that meets the very stringent regulatory standards, and then you apply the RFID or the other sensor devices to supplement the security and the safeguard side. So just one last one. Jimmy keep reminding me. This, by the way, is a QR code. Okay, if you would like to get a copy of this slide, and all you have to do is to do this. Right? Scan the QR code, and then you will get a copy of this. And as I said before, I will be here tomorrow and Thursday. The booth number is E as in Edward 018. And stop by, and I'll be more than happy to talk with you. And if possible, I'll show the live demonstration. Thank you very much.